decay rate of thulium-171 is 30.30309% per year. A sample of thulium-171 has a mass of 900.764 grams. After how many years would there be a mass of 5.749 grams? We're going to use our growth and decay function, our growth function. C sub n is equal to C sub 0 times 1 plus growth rate. In this case, it's a decay rate, so it's going to be negative, to the power of t, time. Let's fill in everything we know. We start off with a mass of 900.764 grams. That's going to be our C sub 0, okay, our initial amount. And we end up with a mass of 5.749 grams, so that's going to be our C sub n. And our decay rate, it's going to be negative because it's decaying. We replace the I with 30.30309%. As a decimal, divide this by 100, you get 0.3030309. When we subtract that, you end up getting 0.6969691. That's all raised to the power of t. And what we're after is the t. So to get the t as long as we can, I'm going to divide both sides by 900.764. Then we end up with, and in the calculator, 5.749 divided by 900.764 is equal to 0.006382. And it goes on forever, so I'm just going to keep that number in the calculator. Then I have this number, the 0.6969, to the power of t. To get the t alone, I'm going to write this in logarithmic form. If you remember, 10 to the power of 2 is 100, and the log of 100 is 2, that this is two ways of writing the same thing. Notice what happens. Our old base becomes the base of the logarithm. Our exponent is the answer, and our old answer is what we're taking the log of. So the log of 100, base 10, is 2. This is like a roadmap of how to switch between exponential form and logarithmic form. Our old base is going to become the base of the log. So we're saying the log of this thing to the base 0.6969691 is going to be equal to t. So we say the log of this thing, the 0.0063824, and goes on forever, okay, obtain the log of that, to the base 0.6969691 is equal to t. And then we can use our change of base rule that says if you have the log of a to the base b, it's the same as doing the log of a, base anything, divided by the log of b, base anything. The log of this thing, base 10, divided by the log of the old base, the 0.6969691 to the base 10 is equal to t. We're using base 10 because the calculator can work in base 10. Handy dandy calculator. This number, the log, gives us negative, divided by the log of this number, 0.6969691 log, and then we're dividing them, gives us 14, like 14.00005. Very, very close to 14 years. I'm going to round it to 14 years. Our time is 14 years. So we could say that there would be 5.749 grams after 14 years. Let's go and see if that is the answer. 14 years. And that's it for a level 13 type question. Have a good day.